In this video, we'll look at a recursive function for displaying a linked list. So I'm using the previous project that already we have seen in the previous video. I have an array of elements and creating a linked list of these elements. How to create? Already I have written a function. This function will create a linked list. How it is working you will come to know when coming videos. Then also we wrote a function for displaying. This was a iterative function. Below this I will write a recursive function for display. So let us write a recursive function. It's a small function void r display, and this will take a node structure as parameter p. Then as the logic we have already seen, that is if p is not equal to null, then printf %d space the value inside a node, that is data. Then call itself r display by passing p's next. That's all. It's a small function. And here inside main function, I will call this r display by passing pointer first. Let us run the program. It should display all the elements in the linked list. Yes, 3, 5, 7, 10, 15. Yes, these elements are displayed by this function. Let us debug this function and see how this recursive function is working and how the stack is utilized. I'll put a breakpoint. Now run the program. Here, as we have seen in the previous video, array and the entire linked list, you can see complete linked list is already there because the create function was already executed. Linked list is created. And here inside this debug panel, you can see the function calls, how the functions all are being made. The first function is main right now and the number is 0 now. Then it will start calling r display and it will be go on calling itself. So this stack size will grow, and here also you can see how the value of p are changing. I will continue execution. Yes, it has reached r display. R display right now p is upon first node. You can see that the data is 3, and here inside this debug panel you can see r display is called. The next it will display the element 3, then it will call upon next node recursively. And you can see that this is the second call, and the pointer is now 77b0 and the data is 5. Continue. Print 5. Call itself upon next node. Now the node is having data 7, and here you can see there are 3 calls so far. So in this topmost call it is here in if, and in the previous call it has called itself from this line, so it is in this line, and the previous call also it is in the same line. Now continue. Print 7. Go to next node. Print 10. Go to next node. Print 15 and go to next node. Now it is null. So inside this watch you can see p value is null. Now it will start returning back. It will go back to the previous node. Just watch the data. So it will be going back to previous node, that is 15. Yeah, go back to 15, then go back to 10. Here you can watch, then go back to 7, then go back to 5, then go back to 3 and end. So it has called itself again and again, and also it has returned back along those same nodes. So this is recursive display. Now I'll make one change here inside this recursive display. Instead of first print then display, I will remove this print and I will write it after recursive call. Then it should print the elements while returning. Function should print the elements while returning. Let us run. Yes, while returning, when it is printing, the elements are printed in reverse. First 15, 10, then 7, 5, 3. See, these elements are displayed in reverse. So that's it in this video. I have shown you recursive function. It is printing the elements in forward as well as in reverse. While returning in backward, it is displaying the same linked list. So I have shown you r display function, which is displaying the elements from left to right as well as from right to left, that is backward. It is printing them while returning. That's all.